So for cadets, I'm Amy from HQ, and we've got the HQSO Met on the call. Dressed in clouds and all the rest. And I shall hand over to Paul to do the introductions.
Evening, everyone, and thank you for taking time out to come and see us. Tonight, I've got two guest speakers, but what I want to do is just sell to you, those who haven't done a Met course, is sell to you the advantages of doing a Met course. No matter what we do, whether it's inside or outside, it is somehow related to the weather and our climate. So it's probably in your interest that we just understand it. There's a lot of myths out there. It's not dark magic. It's actually quite simple. I was a dropout from high school, and now I've got a postgraduate degree, certificate of education from Plymouth University. So if I can understand it, then you guys certainly can. So what I'm going to do is I'm going to hand over to our first speaker, which is Fran. Fran was in the course ahead of me, going through the Royal Navy's Weather Forecaster School, and she's just finished her senior meteorologist's course, the long course. Fran is a STEM ambassador as well, and is based down in the Royal Navy Air Station in Culdrose. So it's quite an exciting time for me to introduce a fellow colleague. Fran has also had tactical HM experience, so been out there not chasing Russian submarines around an ocean that we can't talk about. So I won't waffle any further. Fran, over to you.
Hey, so I've got a presentation that I think we're going to share.
Yeah.
Great, thank you. Fantastic. So evening, everyone. My name's Lieutenant Francesca Allen, and I am a HM officer in the Navy. So that means hydrographics and meteorology. And yeah, I'm going to talk to you for about 15-20 minutes about what my job is, why I chose it, why I love it, and what I get up to. And then we're going to have a bit of time for questions as well. Cool. Next slide, please. Thank you. So what is my job and why did I choose it? So in very basic terms, as Paul said, I am a weather forecaster, but the Navy's term for that is hydrographic and meteorological officer. That first word, hydrographic, means surveying the seabed. So the Navy sees us as scientists. We do a bit of that as well. So making charts of the seabed. And then the second word, meteorologist, that is basically the technical term for a weather forecaster. So the Navy has its own weather forecasters because, as you guys, it sounds like you already know, what we do at sea is so subject to the weather. We are at the mercy of the weather all the time. And you'll know that from when it's been sea state 6 and you're feeling sick all the time, or really cold or really windy. Whereas the Army and the RAF, they use Met Office forecasters. So they do the same sort of job as me, but they're civilians. They're not actually part of the armed forces. So the Navy does very particular things in terms of weather. The most dangerous things we do is operate aircraft at sea off ships such as the Type 23 frigates and the aircraft carriers, the brand new ones we've got. So anywhere you see a ship with an aircraft on it like that, you've got someone like me doing the weather forecasting for it. So that's what I do. Why did I choose it? Well, I thought it sounded really interesting. I did GCSE options in geography and French and music, and then I went on to do A-levels in geography, French and chemistry. And I wanted something that ideally tied that all together, which is a little bit of an impossible ask. But I also really enjoyed being in the guides. So there wasn't a Sea Cadet unit where I grew up, but there was guides. And I liked that kind of idea of joining a uniformed service, but also being a scientist. And I thought it was too good to be true that the Navy had this branch where I could do a bit of both. And then another key factor was that the job was really reliable and it was well paid. And it gave me something called a pension, which I might need when I was a bit older as well. So that is definitely a huge contributing factor. Next slide. There we go. So after school, where I did my A-levels, I went to the University of Southampton. which is where they have the National Oceanography Centre. And there you can do a degree in something called oceanography, which is quite literally the study of the oceans, so the geography of the oceans. I chose that degree because I really enjoyed the more physical side of geography at GCSE and at A-level. And I liked the sort of environmental science side of things as well. And I really liked sailing. I'd never actually been to sea at that point, and I didn't know that I got seasick, but I really just liked sailing. And I thought, what job can I do that involves science, being at sea, being in sort of uniform service, something's going to pay me well and be quite reliable. So I did my exams to join the Navy when I was still doing A-levels at school. And they said, fine, you've ticked that box, go to uni for 3 years. And after you finish at university, 2 months later, you can walk into Dartmouth, which is the officer training college, and you can have a guaranteed job. Long story short, that was about 10 years ago. And the plan actually worked. I've stuck to the plan. It's gone really well. And that's how I am where I am today. Next slide, please. So some of you may recognise this picture. This is the Dartmouth College, so Britannia Royal Naval College in Dartmouth. And this is where all officers go to do at least one element of their training. We start off here doing basic training, and then different specialisations go to different places. So I spent a year here when I was 21. So I finished uni and I went straight here, and I basically lived here for a year. So the first bit was doing all that difficult stuff, marching around, getting up really early in the morning, walking on the moors for days on end in the cold and the dark, running around and being beasted basically. But they got us through the basic stages. And then I went to sea for a little bit, which we'll come on to later, to effectively do some kind of work experience for a couple of months. And then I did another couple of months of technical studies at the college, so more sciencey stuff. But overall, really enjoyed it. And you guys will probably recognise that picture, but it's a beautiful place to live, very lucky, especially when the sun is shining. Next slide, please. So after I was at Dartmouth, and part of that, sort of the work experience time, they train you in all the basics, and then they say, right, off you go to sea and see if you can really handle it. And that's called Specialist Fleet Time, where it was when I went through it, SFT. And that for me was about a year. And I spent that year on this ship here, which is HMS Kent, a Type 23 frigate. And it started off in Rosyth, which is a dockyard in Scotland, bringing the ship out of refit. So it had been in some maintenance periods, it had different engines changed basically, some sonars added, things like that. And I went on as a young trainee to find out everything. So you've got a ship there and you see it's very literally not attached to the land. So when you sail away from land, you have to take absolutely everything with you that you might need for however long you're going to be at sea. And for these ships, that might be sort of 6 to 8 weeks before you stop and refuel again. So you have people on there that can cook meals. You've got chefs. You've got people that clean, which is all of us. You've got people that drive the ship and navigate the ship. You've got weapons engineers that deal with electronics, and you've got marine engineers that deal with engines. You've got logistics officers that deal with stores, and then you've got the warfighting team that deal with coming up against the enemy and all the tactics involved in that. So part of my year's work experience on HMS Kent was doing a small bit of time with each of those departments. So I learned the basics of every single job on that ship. And the Navy's core tagline is the team works. It's really important that everyone has an idea of what every job involves on the ship, so you have an appreciation of the team that you're working with. Next slide. So at that point, I'd been in the Navy about 2 to 3 years. I'd done my basic training and they checked that I could survive at sea for a couple of months on a ship. So that was a big tick in the box. And once you've done all of that, you go off to specialise. And my specialisation was the HM branch. So I went to Plymouth, as Paul said, and I spent about a year there in 2013, 2014, learning the real detail of the weather. It's basically a degree in the space of a year. And this is part of what we did. This picture here is a weather balloon. So it's quite basic technology, but it's something we really still rely on. It's literally releasing a balloon up into the sky. It goes up, it collects lots of data about temperature and humidity way, way up in the atmosphere. And then via very simple radio signals, really, it sends that data way back to us. And if we know what's going on in the atmosphere in terms of temperature and humidity, we can literally work the weather out. Had to have quite a lot of training to work to get to that stage, but that is the basics of it. It's all we need to know, the temperature and the humidity right up there in the atmosphere. And from that, we can work out what the weather is doing on the ground. Next slide, please. Thanks. Right, so this is now a picture of HMS Echo, which is a ship that I went to after my basic HM training. So I'm a weather forecaster, but the Navy asked us to be multitaskers really. So much like Paul, I've got some basic training in hydrographic surveying as well. And it was on this ship, HMS Echo, that I went to do that. It's probably quite young, most of you to remember, but in 2014, there was an aircraft that went missing from Malaysia. And they thought that aircraft had landed in the sea off Australia. And in order to go and look for that aircraft, perhaps at the bottom of the sea, they sent HMS Echo, which was the ship that I just joined. So I was brand new to the ship. One of my main roles was doing the weather, and I was sent out to the Southern Ocean just off Australia to help do the weather planning for that search for that aircraft. I was around 24 years old at the time, and I thought that was just fantastic. I couldn't believe I was so lucky to be able to go and take part in that operation. Next slide, please. So after that period of time, I went to a different job, which was based out of Plymouth. And as Paul referred to, most of what we do in the Navy is also focused on hunting for submarines, so enemy submarines. The thing about submarines is they go underwater and you can't see them. They're really difficult to find, but there are some things that we can do in terms of the oceanography, so the environment that those submarines are operating in. If we know all about that, then we can find them better than they can find us. So I did a couple of years doing that kind of stuff, going on and off ships, looking for submarines around the UK and further afield as well. Next slide, please. And now we come to more recent times. So this is a picture of the air traffic control tower, which includes the Met Office, a Merlin Mark II helicopter and an aircrew person, so probably a pilot there, at RNAS Culdrose, which is the air station down in Cornwall, where I currently work. So this was a period of time, starting about 3 years ago now, where I focused more on really in-depth weather forecasting for aviation. So these helicopters can operate up to around 5,000 feet in the air. And you think we're an airliner that you go on holiday on, they operate around 30,000 feet. So still relatively low, but they need to know, these helicopters, what the weather's doing, what the winds are doing, if it's going to be very cold, if it's going to rain, or they're expecting any snow or ice, that kind of stuff. So we have to provide quite detailed weather forecasts to these guys 24/7. So a new weather forecast goes out, made by someone like me, every 12 hours, and that goes on constantly, overnight, over the Easter weekend, over summer holidays, absolutely everything. So someone like me sits in the air traffic control tower in the Met Office, and we use loads of satellite data, really complicated technology, but we bring it back to making a weather forecast similar to that you basically see on the TV. Next slide, please. Yeah, so leading on from that, as you can see from Paul's background, this is probably a chart that you guys recognise, either from your training or from watching Carol on BBC Weather or any of the weather apps that you might have on your phone. So knowing all of that data that comes from the weather balloon, this is the kind of chart that people like me create, and people like you or people like aircraft pilots perhaps use. And in your training, I've learned all about cold fronts and warm fronts and occluded fronts and all the different weathers that are associated with them. But this is the kind of stuff that I deal with on a daily basis. Next slide, please. Thank you. So this might seem a bit random, but this is a picture all about space weather. So sometimes when it's National Space Week, I've gone into schools and talked to them about space weather, because all of our weather is driven actually by what happens in space. So the fact that the Earth is heated by the sun and the hot air travels all the way from the sun to the Earth drives our weather, because that heat has to go somewhere when it arrives at the Earth. It evaporates, it condenses, it drives warm fronts, cold fronts, and just dictates really whether it rains or not. It's that simple. But an awful lot of the technology that we now use with satellites up in the air to forecast the weather is also subject to space weather. So there's all sorts of things to do with that. If you want to get into it a little bit more, literally Google space weather. It's an area I find really interesting. Next slide, please. So this explains a little bit more really about space weather. If some of you are doing sort of science GCSEs or thinking about perhaps doing physics or astronomy, it's that kind of area. So we'll just touch on it briefly now. But we use satellites, we use solar charging panels up in the atmosphere, and all that information has to come through the atmosphere. It affects things like passenger aircraft travelling really high up, but it also affects things like your Wi-Fi signal and whether you can get VHF signal down on the ground. So I thought it was just a nice graphic. You briefly look around it while I'm talking around it to just describe how much space weather can really affect everything we do on Earth as well. Next slide, please. So highlights of my job, what's really good about it? The fact that I get to travel. I'd been in the Navy only 3 years when I ended up in Australia. And during that year coming back from Australia, I went to places like Bahrain, Singapore, lots of places in France, Gibraltar, literally the whole world. We ended up bringing the ship right back from Australia. I've mentioned it before, I got really good pay, reliable pay and a pension. So things that will back up my future in terms of money and finances. It's a reliable job. Unless you do something super naughty, you're not just going to get sacked. You're not on a short-term contract. It's a reliable, long-term form of employment. I like the fact that the Navy allows and sort of supports you in doing sport and fitness. So I'm really into running and sailing, and those things are something that the Navy allows and actually encourages you to have time for, which I thought was just fantastic. People, so you opt to join the Navy, which is kind of, it tends to be a certain personality of person that does that, and I have not fallen out with anyone that I've worked with yet. All the people that I work with are just fantastic, and that makes a real difference as well. When I was sitting there at sort of 17, 18 deciding what to do, I thought I want life experience, and that will mean different things to different people. Each of you will have your own definition of what that might mean, but I basically wanted to go places, do stuff and do a job that would make a bit of a difference. And I can safely say, sitting here now 10 years into being in the Navy, it's really worked out and I'm thoroughly enjoying it. Different postings every 2 years. So some jobs you might join and you could be in that career in that one office at that one desk forever. That might be something that you definitely want, but it might also be something that you think that would be a nightmare. The Navy gives you jobs that change every couple of years. So I've been in lots of different places so far. There are some downsides to that. It's hard to put roots down and decide where you want home to be, but at the moment the benefits outweigh the costs of that. And that then leads on to the variety of operations you're involved in, the variety of experience you get, the variety of people that you work with. The military, or any form of employment in the military, is a really good basis for employment later on. If you then end up leaving the military, you're given a great set of transferable skills that you can go on to use in basically any job in the future. And the final point there, the highlights of the job, I like that it's quite a cool job and that it's quite an unusual type of work. I find that really nice, and it's still a major contributing factor to why I enjoy it. Next slide, please. So it would only be fair to talk also about some downsides to my job as well. I have mentioned before, it's being away from friends and family. I didn't mind that so much when I was very young, footloose and fancy free, didn't mind going away, didn't feel homesick, didn't really miss my parents or where I grew up. But I'm now married with 2 kids and things like that change. But the Navy is coming round to more flexible way of working that supports family life. This might come as a shock to you, but when you are on that ship and you are at sea and you're not physically connected to land, you don't have Wi-Fi. You're not going to be able to go on your phone and go on Facebook. You're not able to WhatsApp people. You get 15 minutes on a satellite phone every week to call home. That's the kind of worst case scenario. So depending on the environment that you've grown up with, that might be a bit of a shock. It might be quite difficult to deal with at times. What we do is quite unpredictable. That is part and parcel of the job that you are asked to do, and it involves short notice changes at times. That can be quite stressful to deal with. I'd like to say that it gets easier. It doesn't necessarily get easier. Sometimes it actually gets harder, but it's good experience to put yourself through and know that you can cope with. Tough rules. So if you join the Navy, you join any armed force, you sign up to abide by their rules, which means turning to at the right time, not being late, looking smart in your uniform, all those things that as sea cadets I'm sure you're already aware of. One major downside for me was that I do get seasick. And I'd sailed small ships around the coast, and I'd done lots of sailing on lakes before, but I'd never been in a sea state 10 on a ship in the middle of the Atlantic. And turns out I do get seasick. They can give you some medication for it. I get over it in about 3 days and then I'm okay, but that is pretty horrible when you're in the middle of it. Last two then, so food. Sometimes when you've been at sea for quite a long time, you're going to run out of fresh food. You're not going to be able to just pop down to the co-op and get some apples. You're still fed, but you're on food that is more like ration packs at the very worst of times. You definitely still get fed, it's fine, but just that is something that you might not realise until you get there. You think, oh, all the fresh food's run out. Yeah, hard work is the last one. This is a benefit and a downside at the same time. It is hard work, but that's what you sign up to do. We get paid really well for it and rewarded. So I think it's definitely worth it. Next slide, please. Yeah, so at the moment I work in Cornwall and down in the southwest. I've been in Culdrose and Plymouth and Dartmouth. I've also been in Portsmouth. But as I explained before, wherever you see a ship, you'll have someone like me doing the weather forecasting from it. So definitely out in the English Channel. But Royal Navy ships are based everywhere around the world. Around the UK, we're based in Portsmouth and in Scotland as well. Next slide. So this is becoming more and more of an important topic, particularly you might be doing it at school at the moment. The Navy is really starting to recognise the impact that it has on the environment, and that there should be a real element of sustainability to what we do. We've got away for a long time with not really considering it, but lots of organisations, especially big organisations, are now making real changes to deal with that. So it's to do with things like how we get rid of our rubbish at sea. Do we just throw it over the side? What kind of fuel are we using in our engines? Does that fuel then go into the sea as well? What impact does that have on the habitats and the environment that we're operating in? Climate change. It was a big thing when I did my oceanography degree 10 years ago, and now it's an even bigger thing. We can't afford to ignore that, and the Navy has its own policy on climate change as well. Every ship that's out and about at sea is constantly collecting data, and that goes into a huge climate change project that we're running as well. So we want to advertise the fact that we're a force for good in environmental factors, really. Those things are being considered. Next slide, please. So these are just some quick slides at the end, really, to show you some of the other stuff that I do. Next slide, please. So within my job, you might not know that there's only about 10% women in the Navy. So for every 100 people that you have in a room that are in the Navy, 90 of them will be men and only 10 of them will be women. So I run something called the Naval Service Women's Network, which is all about improving the experience of women that work in the Navy. And this is just a really nice picture of us and the group that I run down at Culdrose, of us having tea and biscuits, basically. This was taken about 2 years ago, so definitely pre-COVID times, but at the moment we're running our group over WhatsApp. Next slide. I do things like I'm talking to you now, so going into schools. This is me talking a couple of years ago at Mounts Bay Academy, which is a school in Penzance, all about what I do, and that is part of my job, and my job pays me to do that, which I think is too good to be true. I really enjoy that element of it. Next slide. And then, yeah, so at the other end of the spectrum, this was a visit that I ran about 18 months ago now with some slightly older people that actually used to be in the Navy at the very end of the Second World War. So this particular batch joined when they're about 16, 17, and the couple on the left are now married, and the lady there had to leave the Navy when she got married to the man there. But now that policy's changed, for example, you can be married to someone else in the Navy and stay in the Navy as well. Next slide, please. Yeah, that's everything. Hopefully that's been about right and about the right time limit, but I'll now hand over for any questions.
That's brilliant, Fran. Thank you very much. While you've been talking, there's been a few questions coming in.
Yeah.
I've managed to field some of them, but there's one or two that are definitely for you.
Okay.
Right, first one. What is the possibility of a solar storm whipping out the Earth's electrical system?
Yeah, it's definitely a thing. So yeah, I know the theory behind it. The problem with that kind of thing is it's very difficult to forecast. We have a batch of people that do try and forecast that stuff, but I'd say the experts in it are the Americans. And it's a really bad thing for me to say, but if nothing else, I would Google it. Like, there are specific websites that try and forecast this thing, and they're open source, they're open to the public, and you can see it. It's a definite possibility. I personally don't know when the next one might be, but something to watch out for.
Indeed, and it's the effect it has on.
Yeah.
It was surprising just how much GPS affects what we do. Not only does it control our navigation systems, it feeds into our mobile phones. The financial markets use it for their transactions, traffic lights, other computer systems, air traffic control. If we lose the GPS signal, which is only 0.4 of a watt when by the time it hits the Earth's surface, that will affect a lot of us. It came as a bit of a shock when we first tried GPS jamming off Scotland, just how many systems it did affect. And I think the world's clutching into the fact that just how much it is. Right, next question is, I like this one. If you didn't do this job, what would you do?
So I'd probably do, and that's a really good question, I'd probably do a very similar job, but in the civilian world. So a backup plan of mine has always been to be a meteorologist in the Met Office. So they are people that you see on, for example, BBC Weather, or they used to be. But I like the other things, those other special things that I mentioned that the Navy and the military bring to my job. Another career that I might consider is becoming a teacher as well. I like the idea of being a secondary school teacher, and all the experience and the training that I've had so far in the Navy would definitely set me up well for something like that.
Oh, brilliant. Thank you. Right. I've kind of answered this one, but I'll hand it over to you for another angle. Why is the satellite time so short? I take it they're talking about our 15-minute welfare call.
Okay. Well, okay. Yeah, that's a really good question. And the answer is money. It costs the Navy a lot of money to have a contract with Inmarsat, I think it is, to give us that, effectively, that Wi-Fi time, that space. We are buying space attached to the satellite. And that costs the Navy a lot of money. And per person that is on that ship, the Navy have decided that they can afford 15 minutes. Hopefully that will change. Wi-Fi is coming on to some ships, but when I was first on board HMS Echo, for example, that meant 7.5 minutes for my parents every week and 7.5 minutes for my boyfriend, and that was it. Depends if you want to be connected all the time or you don't. But yeah, that is why it's all about money.
And of course, there is the other thing that we're using basically a radio transmitter, albeit to a satellite, and that can give your position away.
Yes, that's true.
And that's what we're using. We're trying to use the environment. We as Fran is obviously more the meteorological and the climate. I'm actually more the oceanography and the hydrography specialist. But that's the sort of thing that can give, and we provide the Navy with the knowledge to use the environment as a weapon. Yeah. So their history is littered with examples of where wars and battles have been fought, and the weather was the decisive factor. The invasions of Russia, Washington crossing the Delaware, invasion of Normandy as well. So we are quite critical and have always been placed in with the command planning, you know, the generals and the admirals and such. And we are usually, in a brief, the second person to speak after the introductions. So it's quite, they do really pay attention to what we have to say. Right, so I was going to answer this one, and I think I'll let you go first. Have you ever been in a sea battle?
No. I personally haven't. I think the most punchy thing that I've ever done operationally is searching for that Malaysia aircraft off Australia in 2014. There are hydrographic survey ships that have gone into battle before the normal ships get there to get all the secret data basically about the lie of the land within the ocean. But Met, especially Met forecasting, we can do a lot from afar. So the answer to that has to be no, I'd say. Okay.
I was in the Gulf War II, yeah. And I was embedded with the Royal Marines, and as we went up the Qusar waterway to invade Iraq. Yeah. That was an interesting time. Next question. Oh, this is more an engineering one. Is it, what would happen if a warship was powered by electricity? Well, we already have warships that are powered by electricity. Fran's ship, HMS Echo, mine, HMS Enterprise, the 45s, the carriers, the submarines are all have electric propulsion motors. Yeah, we're already there.
Yeah.
It's the future. Right. Have you ever seen a ship sink? Sadly, I have. And the second question was the Malaysian plane in the ocean?
So long story short, no, we never found it. So my ship Echo was sent there because it had a sonar that could pick up, or should have been able to pick up, the signal from the black box recorder. But where we think the plane went down was so deep, it was about 6 kilometers deep of ocean, that we would have never found that signal, because the signal only goes out for about 2 kilometers. What they did find is they found wreckage that they thought was from the aircraft washed up actually on the shores of, is it Tasmania and the eastern shores of Africa, basically. So the debris had gone all the way across, and they're still finding bits of it now. But the mystery really hasn't been solved. Very sad.
Yeah, I think that's it for the questions here. I'm just going to share a screen from my point of view as a hydrographer.
Yeah.
And show you this. This is what I did last year. You should be able to see it. For those of you who can't see it, what you're looking at is a ship on the seabed. That's a very specific ship. That's the HMS Prince of Wales. And that's off Malaysia. We went over there. That sank in a Japanese air attack in World War II. And what's significant is if you look down the middle of the ship, you see all these chunks that are missing. And what's sad is that is an officially designated war grave. But because it was a ship that was made before the atomic bombs went off in the atmosphere, the steel is very attractive for medical devices and other high-end metalwork. It's pre-atomic steel. So salvage hunters have come over the years, even though it's a war grave, and they have ripped bits out the hull to use then to sell at very high price to scrap metal merchants. But that's kind of what I use, and we use a lot of sonar that Fran was talking about. I've also got some unmanned underwater vehicles, 2 Remus robots. I've got a drone, which I was using this week on Devil's Island in Plymouth Sound. And also we've got an unmanned boat, 2 of them, sorry, that drive around and basically spread the load. The idea being is we could put those into a hostile area, let them collect the data, and then pave the way for the Royal Marines and their landing. Fran, I'm really grateful to you, and thank you very much for spending some time. I know you've got other commitments, so if you need to cut away, feel free. But as a sailor, I think you'll find our next speaker rather interesting, particularly as he's only down the road from you. So I bumped into Simon a while back. I went up to the RYA house and watched Simon teach you weather in a day. It was quite impressive, and during that day Simon actually found time to tell us about his exploits with the British Olympic team. Simon, I could rattle on, but I actually think they want to hear you talk, not me.
Excellent.
Well, stop the sharing. Sorry, there we go, and it's all over to you.
Excellent. Well, thanks very much, Fran. That was a great talk. That really interesting. I think you definitely win the award for being the proper grown up in the room tonight, because I certainly am not. Anyway, thank you very much for asking me along. I'm not going to talk entirely about meteorology though, because I also think I'm probably the most ancient person in the room as well. I'm 55 at the end of this month, and I've got a few. I've been on a slightly interesting route to, well, I think it's interesting anyway, to become a meteorologist. So I thought I'd just start a little bit further back from that. Let me just share my screen, and I'll bung a few photos up. Hold on. This is the first time that obviously the first thing that you'll see that I really am ancient, because this is of course all going to go horribly wrong. And I need a 14-year-old to tell me how to work. Okay, here we go. Brilliant.
Now you're there. It's all there.
Good, lovely. Right. Well, my main job at the moment is I'm the meteorologist for the British sailing team, and the photo on the screen there, that's the Olympic sailing venue out in Japan. The island that you can see in the front there, that's Enoshima, and it's connected to the mainland by that long, low causeway that you see along there. And the mountain in the background is Mount Fuji-san. We were obviously hoping to be out there for the Olympics last year, but we will, touch wood, be there later on this summer for the Olympics. And I hope you can watch some of that. So it'll be on from the last week in July and the first week in August. So roughly the 23rd of July through to the 7th or 8th of August. Yeah, it's doing the forecasting for the Olympic team is good fun, and I'll tell you a little bit about that later on. I didn't start off there, as I said. I mentioned I didn't start off as a excuse me, as a meteorologist. I started my working life as an engineer. I've always been a bit of a geek, and I did the classic maths, physics, and chemistry at school. Excuse me. I was actually a sea cadet a million years ago, but it didn't last because I grew up out in Zimbabwe, in southern Africa, and Zimbabwe is an entirely landlocked country. So quite why someone thought it was a good idea to get the sea cadets going, I'm not sure. But I was a sea cadet for a year before someone realised that we couldn't actually find any sea, so it wasn't really useful. Anyway, so I did maths, physics, and chemistry at school, and then went to do engineering. I did electrical engineering. I did my degree at Imperial College in London, and graduated back in 1989, a million years ago. When I graduated, I managed to get a job in the oil and gas business, working doing geophysical and geological surveys of oil wells. I worked in a few places. It was interesting. I trained out in Argentina for 4 months, which is really good fun. It's a lovely country with great people, and everything's just really big out there. If you're driving along, you see a hill. When we did this, we went away camping for one weekend from the training school there, and we thought we stopped for a lunch break on the way there, and we thought, well, there's a wee hill just next to us, so we'll have a yomp up the hill. And then we got to the top, and it was a whole lot bigger than it seemed at first. Then from there, I started work. My first actual time as a proper engineer was offshore in the North Sea, working out of Aberdeen. And the oil rig you can see on the left-hand side of the screen there, that's the Claymore Alpha. I spent a lot of time on there, all fairly industrial. I then got transferred to Oman in the Middle East, and worked in a place called Fahud in the middle of the desert there. Excuse me. And the photo on the right is of a typical land rig in the desert, and actually there's a little truck, or it's actually quite a big truck, down the bottom left-hand side, left-hand corner there. That looks very much like the sort of thing that I used to take to a rig, because what we would do there is we would basically survey the oil well once it had been drilled, to tell the oil company what they had there, because what an oil rig does, it drills a really deep, very thin hole into the Earth's crust, going down anywhere from, say, 1,000 to maybe 5,000 or 6,000 meters down. And this hole is maybe only 20 to 25 centimeters across, but it's kilometers long. And what someone like me would do is I would go there with my crew, three or four technicians, and we would set up, and on the end of a very long cable, a wireline cable, which was called a wireline cable because of the electric wires going up inside it, we'd send down a sequence of different probes that would measure things like the density of the rock, how much water was in it, did it conduct electricity? And you think, well, why do we care about that? Well, basically, water conducts electricity, but oil and gas doesn't. So you can work out from those readings what the rock contains and what type of rock it is, and whether it's actually viable for that oil well to produce. It was quite fun. Bearing in mind I joined this company when I was 22, and so now I'm a 25-year-old engineer, and I've basically got the entire oil rig waiting for me to finish my job, and my job entails lots of electronics, lots of data gathering. We also had we used radioactive sources to provide spot signals of gamma rays and alpha radiation for different things. We used to play with explosives as well. We used to use explosives, and because there's a lot of underground explosive work that needs doing on oil rigs. So it was a really fascinating job. I got transferred from Oman to Pakistan, which was great. That was another land rig, and I really enjoyed that job. I liked Pakistan. It was a great country, really, really nice people there. I could have happily stayed there. Anyway, finally got transferred back to Aberdeen, and then I got promoted, which is a terrible thing, and discovered that I really didn't like being a manager. So I left that in 1997, and I went sailing from there. Now, I hadn't done any sailing before then, but I thought it sounded like a good idea. So you can see a certain difference between my career path and Fran's. Fran's seems to have an awful lot more thought into it. I was just having fun, and when I stopped having fun in the oil business, I left and went and did something else. So anyway, I learned how to sail. I went down to Cowes on the Isle of Wight to the UK Sailing Academy, UKSA there, and I did one of their 14-week yachtmaster courses. So this is now in 1997. I'm 31 now, and I got my yachtmaster ticket, my yachtmaster offshore ticket, and started working on one of their boats. They'd just bought a 20-meter challenge yacht. You may have seen them around on the water. It's a 20-meter yacht, a cutter-rigged sloop, so single mast, 2 headsails and mainsail. And we used to take, there was the skipper, the first mate, and me, initially the second mate, and we used to take 10 students out sailing for 2 weeks at a time. And the great thing about going sailing on a slightly larger yacht is that the loads are so much bigger, so you have to be really careful about things like using winches, hauling the sails around. So it's a really good teamwork thing, because you've got to make sure that people understand what they're doing so that they're safe. Because that's the very first thing you have to work out on board. Everyone has to be safe, and that's not just being namby-pamby about it. That's efficient. That makes things work better, because if people feel safe, then they're more likely to actually be safe. And if they are safe, then they're going to be confident and happier in their work. And that's a really important thing on a boat of whatever size, be it a small little yacht or a large ship. You have to have people basically happy and getting on, and an important part of that is being safe. So I worked there for 2-3 years. I was going through the Royal Yachting Association instructing scheme, so I got my Yachtmaster instructor's ticket. Then I did my first ocean passage, helped to deliver a yacht from the Canary Islands across to Antigua in the Caribbean, which still remains my favourite Caribbean island. Fabulous place. Really, really, really good place. Lovely, lovely destination and great people there. So I got my ocean yachtmaster ticket, which involves understanding more about worldwide meteorology, and also doing things like using the stars and the planets and the sun and the moon to work out your position using a sextant and the various tables. I always found that my engineering background was very useful in sailing, because if you're at sea, then there's normally a little bit of numerical work involved. If you're navigating, if you're calculating the tides, if you're working out a course to steer, if you're finding your position, being competent at least with numbers is a very good thing. And of course, all boats these days have a lot of electrical and mechanical systems. So because I was an engineer, I still am an engineer, just not an official engineer anymore. I've always been good with spanners and electrical stuff, and I'm extremely good with large hammers, which is very handy on a boat. So I found there were lots of transferable skills there. My sort of logical brain was good for working out what was happening at sea. So I worked up from being mate to being skipper, and was an instructor for 3 or 4 years before I got a call from the Clipper Around the World race, and I was lucky enough to be selected as one of their skippers. And this is me showing some precision navigation work here. This is on our way from, this is in the 2002 race, which is the Around the World race on 8 identical 60-foot yachts with 13 people on board, up to 13 people on board. And back then, this is now 2002, 2003, there was only one professional sailor on board, the skipper, in this case me. And so getting the team involved, getting the crew involved, and really contributing was so important. This is we used to have a briefing every day at lunchtime, where I'd get a chart out, and this is obviously a very nice day, and I wouldn't do this if it was blowing a storm. We'd do the briefing down below, but I'd tell everyone where we were going, what I thought the weather was going to do, and I made it a very important part of my skippering routine to make sure that the crew understood that they could tell me about anything. Whether I could do anything about it is a completely different question, but it was really important that people feel involved and feel part of the team and feel that their contribution, whatever it is important. Because I'm sure as sea cadets, all of you have been on boats of one sort or another, and every job on board is important. This is maybe not immediately obvious, but the person who's cleaning the bilges has just as much effect on the boat as the person who's doing the navigation, because if you're cleaning the bilges properly, you don't have muck getting into the filters, which doesn't then block the bilge pump, which you might need in a hurry if something bad happens. So these sort of things are very important. And we had, that was a really fun year. The race took us from the UK across to Cuba, then through the Panama Canal down to the Galapagos Islands, which are just fabulous. Then we had possibly the best sail I've ever had in my life, from the Galapagos Islands to Hawaii, which was 28 days under spinnaker the whole way. Absolutely fabulous sailing. It wasn't all glamorous though. From Hawaii, we went up to Japan, to Tokyo, which is my first trip to Tokyo. And this was 2 days out. We had 60 knots, good steady 50 knots, gusting 60. So what's that? That's a 4 to 9, gusting 11. And we were going downwind. That's me standing on the backstay, typical yacht skipper position, wondering probably something really important, like when is my next cup of tea arriving on deck. One of my excellent watch leaders, Jane, she's on the helm. She was one of the best helms on board, which is why she was sailing in these hideous conditions. And Maggie next to her was on what we used to call shotgun for the helm, because we always have someone next to the helm just in case anything dramatic happens. And she was also looking at sail trim there, though. In those conditions, sail trim was more a case of just hanging on and making sure that we didn't break anything than anything else. We eventually finished up from Japan. We went down to Singapore, then across to Mauritius, round to Cape Town, across to Brazil, up to New York, back to Jersey, which was I was on skipper of Jersey Clipper, and then we finished back up in Liverpool on a beautiful, beautiful day, and we were really happy because we won the race overall, and we were really chuffed with that. And that was when I first started really getting into meteorology properly, because if you're in a one design race, and what that means is that all the boats in the race are the same, with the same equipment, same rules, the same information coming to them, then there's only 2 things you can do to win the race. You can make your boat go faster, and that's all about making sure that your crew works well and are happy, because if your crew are working well and happy, then your boat will go faster. And the second thing is pointing the boat in the right direction, and that's all about weather. So that's when I started really getting into it then. From there it was I kept on thinking about weather. And back in 2009 now, so about 12 years ago now, I decided I should do something about it. So I went back to university. I went to the University of Reading to do a master's degree in meteorology, a 1-year university course. It was a bit of a shock to the system, because of course to do a university course, you have to be reasonably good at the basics of whatever that course is. So, and I hadn't actually done any maths for about 15 years, apart from just basic stuff on boats. so I had to redo A-level maths. Well, I didn't have to do the qualification, but I had to learn up again to get up to A-level maths standard, and a bit of physics and things like that. But I had a really good time there. I loved that course, and of course, because I'd spent the 12 years before then at sea being rained on, I could every time there was a question, pretty much every single lecture, I'd go, oh, that's why that happened. Oh, of course, that's why that happened. They had to tell me to shut up in the end, because I've got a story about that. Shut up, Simon. We've heard it. Anyway, so that was good fun. Then after that, I started teaching, not to schools, but to other sailors, to yachtmaster instructors, which is where I met Paul. I put together this one-day course, trying to basically give instructors a better understanding of how the weather works, and also maybe some skills or some different techniques, so that they could help explain it to people. And from there, really, from a case of being in the right place at the right time, I was taken on as the meteorologist for the British sailing team about a year before the Olympics in Rio, which is where this photo is taken from. And this is the team. Everyone in the red tracksuits is an athlete, is one of the sailors. So we had 15 athletes in the team, and everyone else is the support staff. We've got coaches, the doctor, the physios, excuse me, team leader, operations management, the bosun to make sure everything's fixed, and me, the weatherman, there at the back where I should be, supporting everyone. And this was great fun, and a real eye-opener for me, because the thing about giving a forecast to someone who's going to use it is that you've got to understand what they need. Fran obviously does this with her pilots and her aviation crews down in Culdrose, which is about 40 miles over there from me. And I have to do it for the sailors and their coaches. So it's really important that I understand exactly what they need. The photo that I've just shown up here, this is, excuse me, this is a practice race out in Japan. You can see the island of Enoshima just in the background. And this is the start of a laser race. Excuse me. What I need to do for the forecast is not tell them where to go on the race course, because that's never going to happen, but to try and give them enough background knowledge so that they can make quicker, better decisions, and hopefully help them to win more medals that way. Because the athletes in the British sailing team, when you get to that level of sailing, they can do everything like tacking and jibing and all that good stuff, just like that. They don't have to think about it, they just have to do it. And if I can help them recognize cloud patterns, look for things on the water, have an idea of how the weather is going to change during the day, and what to look for that, that's going to really help them make those better decisions faster. I don't only work for the British sailing team. I work for several other clients. So for example, today I've given forecasts out to a 60-meter motor yacht, a beautiful, beautiful boat, which is in transit back from the Caribbean to Gibraltar. They're about halfway across today. There's also 4 very sweaty men in a rowing boat going from the Canaries to Antigua. If you do a search for Monkey Fist Adventure, you'll see them. They're doing 60 miles a day, so average of 2.5 knots and going well. There's a 33-foot French yacht, which is that's a family sailing across, and they're left from the Azores. They're going to the Caribbean. And really exciting for me, I did my first forecast today for the British cycling team, because I hope to be doing some forecasting for them out in Japan, out at the Olympics. So we're just doing I'm not really a cyclist. Last time I was on a bike was 30 years ago, and ended up with me in hospital and the bike and the skip. So we're doing a couple of test runs to see that I got a grasp of what they need. So I've also forecast for some interesting people before. The Australian rugby team and the Rugby World Cup, the Wallabies. I was doing the weather for them. Really, they were after when it was going to rain and when it wasn't going to rain. So I'd watch all their matches with the rainfall radar next to me, and send in updates every 10 minutes or so, just to tell them what was happening or what wasn't happening. I've done forecasts for television production companies. I don't know if any of you have seen Bear Grylls The Island. I did the weather forecast for the safety vessels for that. So the important thing, I think, one of the great things about meteorology, even though it is a very scientific subject, it's also really good for talking to people and understanding people and helping them in their lives and in their days. And that's what I really enjoy about it. I got here via a fairly convoluted route, but everything that I've done in my working life up to now has helped me get where I am today. My engineering work, my sailing itself, and then my meteorological work. It's helped me to become a better meteorologist for my clients. And I think I can make at least a small difference to how their day goes. So I think that's enough waffling from me. Thank you very much for listening. I hope you haven't fallen asleep. Questions, please. I'll just stop sharing this. Ooh, lots.
You're on mute, Paul.
Paul, you're on mute. Oops.
There we go. Apologies for that. Yes, right. Yes, Simon, they've been coming in thick and fast, these questions. So I'll just, without further ado, we'll just get them back up, scroll back to where they were. Right. So first one about oil spills. How many oil spills have happened? Connor, far too many is the honest answer.
Yes, absolutely. Far too many is the honest answer. What I can say though, from my time in the oil business, is that the bigger oil companies, the ones that actually that put a serious amount of money into this stuff, they put a lot of time and effort into actually thinking about how to minimize this. If for no other reason, it costs an absolute fortune to fix up and to clean up. So it's a high risk business to be in, and it's a high risk environment. But as far as possible, the dangers to the environment and to the people are minimized. If I think back to the stuff that we used to deal with, there's enormously high pressures there. There's hazardous materials, or the stuff that I used to deal with on a daily basis, explosives and radioactive sources. There's procedures to handle those. There's things you have to do. Even just living on an oil rig, it's like living on a big ship. You can't just get your spanner and open a panel up and start working. People have to. There's a work permit system, so that if you're trying to fix something, you don't blow the whole thing up. For example, I'm exaggerating a bit there, but that's the whole purpose of this thing. So. But basically one oil spill is too many. But the oil industry does spend an awful lot of time trying to minimize that, and that I think anyone who works at sea tries to minimize that, because we've all seen it. You spill a small amount of diesel into the marina, and it just goes everywhere. You can have half a cupful, and it looks like the Exxon Valdez, or it looks like the Gulf of Mexico spill just next to your boat. And that's terrible. So I know that every boat that I've ever worked on, we've tried to minimize that sort of thing, because it's just the only sensible way to do it.
Brilliant. Now the next one, I'll rephrase this question. So the next one, did anything ever blow up? Well, it's worth mentioning that actually using explosives is a way of surveying. But then I'll hand that back over to you, Simon.
Yes. When I was working on rigs, nothing blew up that shouldn't have. Put it that way. We use explosives to make shocks into the ground, to send sound waves out, to get them back, to work out seismic surveys to see where the layers of rock are. I mentioned that an oil well is a very long, very thin hole. If you just left it there, it would collapse. Excuse me. So basically, when the hole is drilled, you then have to line it with basically metal piping called casing. But the problem is then you can't get the oil and gas in, so you then have to go down and fire shaped charges to make holes in the casing to allow whatever you're trying to get to come in. So that's sort of things that I've made blow up, and they've all worked, and they've all worked as they're supposed to do.
Brilliant. Okay, so sorry, I've just missed it right here. Anything blow up? Right, next one. Moving on to the challenge yachts, which was interesting. I'm glad you mentioned those because I took one to Antarctica.
Brilliant.
Shackleton Exped with Steve. It'll come back to me. The Australian guy, Challenge Antarctica. What's yacht's top speed?
Depends on what type of yacht it is and how long it is. There's a if it's a displacement monohull, or it's been a while since there's it's something like the top speed depends on the hull length. It's something like 1.4 times the square root of the yacht's length in feet, but I could be wrong with that. I'm sorry. See, maths always comes in useful. But it depends really. If it's a displacement boat, in other words, it's not foiling, it doesn't pick up out of the water. If it has to displace the water that it goes through, then it's a function of its waterline length. And the 60 to 70 foot yachts that I've sailed, the fastest that we could go normally was about 10 or 11 knots. However, that photo that I showed you of us coming into Japan, the Pacific is a very big ocean, and the Western Pacific has some very big waves in it, because waves depend on the strength of the wind blowing over the water and the length of time, the length that wind has blown over. That's called a fetch, and the fetch in the Pacific is several thousand miles. And we were surfing down some massive waves, and that was on that particular boat on that particular day we got 22.25 knots, which is the fastest I have ever been on a sailing boat. However, if you use modern technology and you start to lift the boats out of the water, hopefully some of you have watched the America's Cup footage recently. If you haven't, go onto YouTube and do a search for America's Cup. It's absolutely fabulous. These boats are doing 50 knots in 15 knots of wind. It's amazing. And what they're doing, they're basically lifting the boat out of the water and flying. And the only things in the water are the foils that they're actually sailing on, sitting on. And on those boats, yeah, like I said, they can do 50 knots. It's phenomenal.
That's brilliant. Well, funnily enough, that was one of the next questions, was what's the biggest wave you've come across?
I was too busy trying to think of how to reduce sail area, so so I wasn't measuring it, but I would imagine it probably would have been about 12 meters. I do the forecasting for the Clip Around the World race now. I have done for the last 5 editions of it, and in 2018 when they were coming, when they were coming back across the Pacific, the whole fleet was in, and I know this state was real because there are Fran mentioned, but there's a bunch of satellites up there, and several of them which actually will measure the actual wave height. And I looked at the wave height and realized that the whole Clipper fleet had been sailing through waves which were actually classed as phenomenal, and that means greater than 14 meters. I've never been anything like that, thank God. But yeah, that was big.
Oh, brilliant. Well, in that case, have you ever thought of doing the Vendée Globe?
No, I'm not mad. Also, I'm not skilled enough. Those boats, they're falling boats. It's fabulous stuff, but I'm just not a skilled enough sailor to do that.
Oh, brilliant! Right. So I know I have, but have you ever nosedived in your yacht? I'm thinking of there's that picture off Cows of the yacht nosediving and then probably going on her side with the spinnaker up.
Yeah, no, not that bad. I've come down big waves, and the problem with surfing down a big wave really quickly is that when you get to the other end, you'll stuff the front of the boat into the back of the wave up ahead, and we've gone from doing 15, 16 knots to about 4 very quickly, which is quite depressing. And the water, I have had water, basically solid water, all the way up to just past the mast, which is a little worrying. But no, I've never actually, thankfully, got the back end of the boat out of the water.
It's quite scary when it happens, that's for sure. Which is interesting, because that's an interesting question. Is the next one. Have you been scared, and if so, what scared you? To be honest with you, from my point of view, the military spends a lot of time in just getting us to react without thinking. So there's been a few things that at the time I haven't been scared, but it's when you look back after it and think, oh my God, did that really just happen? and how am I still alive? Has that happened to you, Simon?
Yeah. Yes. No. I think anyone who says that they're the most worrying times I've had at sea are when I've been skipper, because it's all my responsibility then. You make sure that the crew understand what's going on and are bought into what the plan is, but then you still have to go and execute it. And yes, there have been moments when I have been seriously concerned and worried. Scared? No, not really. Extremely worried and apprehensive, yes, but I've still been able to think about what's going on and work everything out. It's afterwards though that you think, oh dear God, when you start to play the what if game, that's a terrible game to play, so I try not to play it.
Yeah, fair one. On more lighter subjects, the next question is, what's the largest ship you helped? So for me, it was HMS Ark Royal, the previous carrier. Fran, have you done anything with the QE and the Prince of Wales?
I haven't, no. So the largest ship that I've driven would be a Type 23, so HMS Kent.
I was just, the question was, what's the largest ship you've helped as a weather forecaster?
I've been on HMS, RFA Argus, which is quite big, but I haven't been on any of the aircraft carriers actually. So yeah, Argus. I don't know how long it is. I can't remember.
What about you, Simon?
For me, I tend to deal at the smaller end of the market. So the biggest one that I've helped is the super yacht that's going across the Atlantic at the moment. She's a 60-meter super yacht.
Brilliant. And the biggest yacht you've been on, Simon?
The biggest yacht I've been on is a Clipper 70. Sorry, Clipper 68. I do apologise.
Oh,
however, the last time I crossed the Atlantic by sea, we did average 26 knots. And I must admit, coming across on the Queen Mary 2 is a whole lot more comfortable than on the
Oh dear, I walked straight into that one.
Much better wine cellar.
Now, we're back to this question again. If you didn't have this job, what would you do?
Oh, well, I've done a couple already. I think, actually, one of the things which I've always done in whatever official career that I've been in, whether it's engineering or sailing or meteorology, was I've always ended up teaching. And I think if I hadn't done engineering to start with, I probably would have done either physics or maths at university, and I probably would have ended up as a teacher, and I probably would have enjoyed it a lot, because I do enjoy teaching people. It's nice when you see that light bulb go off, and it's really nice when it doesn't go off immediately and you have to try and explain it in different ways. I like doing that. So I think, yeah, if I wasn't doing what I'm doing now, I'd probably be a teacher.
Oh, brilliant. Now, this one's gone back to, I think, the explosions. And your oil exploration time. Any earthquakes as a result of your seismic, or just any earthquakes, full stop?
No earthquakes, and no resultant stuff. I suspect you're thinking of a technique called fracking at the moment, which is quite big news right now. And what that involves is actually not taking stuff out of an oil well, but actually pumping in high pressure fluid to fracture, which is where the name fracking comes in, to fracture the rock formations underneath there. And what that does, it basically puts more cracks into the rock formations underground, which the theory is that allows the more cracks you have, the more oil and gas can come in, and you can get it back up that way. And this is quite I don't know enough about it to have an opinion, so I can't say whether it's a good thing or a bad thing. But there is a lot of there are questions as to whether that act of basically pressuring up layers of rock underground causes geological movement. That technique wasn't being used when I was in the oil business, and so no, I've never seen anything. I've never seen any earth move that shouldn't. Oh,
that's a relief. That's always a good sign. It's worth pointing out to those who didn't know, the Boxing Day tsunami that took out a lot of the Indian Ocean was caused by a landslip triggered by an earthquake, which happened deep out in the Indian Ocean, and then just the resulting rush of water. If you know, when you push in the bath, same sort of thing, but just on a much bigger scale, was caused by this landslip. Right, this one's a bit morbid. Has a fire ever broken out on your boat? I can speak in my naval career, yes. And because we were out in the Atlantic, we couldn't call the sea police or the fire brigade. It was down to us. And we made the re-entry and we recovered the compartment and got the ship back on sailing. Were you ever unlucky enough to have a fire, Simon, in your time?
No, thankfully. Neither on oil rigs nor on boats so far. The nearest I've come to that was I was the engine compartment on the 20-meter challenge yachts is just big enough so that someone like me, and I'm not small, can lie on top of the battery banks and do whatever's needs doing to the engine. So I was down there doing a bit of maintenance with the engine running, because that was what we needed to do. And I looked up to the chap who was on the engine controls, and I went like that to get him to turn the engine off. And he pulled the fire extinguisher lever, which did turn the engine off, thank God, but also basically set off these halon fire extinguishers, which is a gas with no oxygen in it, which successfully puts out fires, but also successfully doesn't keep you going if you take a breath of it. I discovered I could get out of a very small space very, very quickly at that point.
That's brilliant. And yes, halon, unfortunately, is no longer a firefighting extinguisher that you can get easily, certainly not in Europe and the UK.
No, I'm quite right too, because it's a CFC, so it's not that good for the atmosphere, for the ozone there.
No.
Yeah.
No. I know a lot of ours is going over to America, but hopefully they'll stop using them soon.
Yeah.
Right. Well, we seem to have got to the end of the questions, and can I just reiterate our thanks again to both of you, Fran and Simon, for taking the time out to just talk to our cadets and tell them that there is a career in meteorology, in basically in environmental science.
Yes, very much so.
And I'm particularly pleased, Simon, to see all those NPs on your bookshelf. You know, as someone who works for UKHO, that fills me with a bit of pride. Oh, there is a new message in. Oh, hang on. Oh no, sorry. Anyway, yeah, no, I'm really glad that you could, and perhaps we could do it again sometime.
With pleasure.
Yeah, no worries. Thank you very much for inviting me, and it's been great to meet you too, Simon. A really interesting talk. Thank you.
Our pleasure, Fran.
We'll put you two together, and you can, mess dinner. Guest speaker.
Oh God, I have to have a haircut.
I think you'll be all right, Simon.
Wow, doing this.
And Fran, thank you very much for the work that you do out there, because I know that you basically help put together the forecast that I actually use. So much appreciated.
No worries.
Oh, I've just had one more come up, and this is being fed back from some of the instructors in a Facebook group. Okay. And I've slammed it down, but I thought just get your take on it. It's the using apps. Yeah, funny enough, they said, "Oh, you just use the same apps we do." Well, I said that's a well-worn excuse by those who never win. And I'd let your gold medals and military operations do the talking.
There's not an app out there that will tell you how to look at a satellite image to work out whether you're going to get a line squall hitting you in 23 minutes. Enough said, I think.
So my point of view would be that the apps give you all the data, that's great, but they don't give you the so what, the implication of that data. You can only know that through training or talking to someone that is trained, like me or Simon. That's what won't do us weather forecasters out of a job in person. You always need that interpretation. And for example, Simon will be able to provide that in relation to his customers, which are the sailors or the athletes, and I can provide that information in relation to my customers, which is the military, which is often, has quite a specific requirement.
Brilliant. Oh, that's fantastic. Thanks again, Fran. Back to you, Amy.
No, thank you very much all for attending. We have seen your questions in the chat, and thank you very much for submitting them all. I think we've all probably had a moment at sea where we thought, oh, goodness, this is scary, but I don't think any of us thought we were going to die on that question.
I'm glad you
trust our abilities. There's the reason we go through all the training, and that's why. So we know how to look after ourselves.
Oh, yeah, for Simon's benefit, Amy was one of our yacht skippers on our Sea Cadet fleet.
Oh, fantastic.
Yeah, so
And I learned to sail on Challenge 72s. So yeah, that was fun.
Great boat.
Thank you very much for presenting this evening. It's been really interesting and really different as well. So great. Thank you very much.
Pleasure. Thank
Have
you.
a good evening.